Now we can draw electric fields, because remember what we said, it is the force that's being experienced by a positive charge. So let's go and draw a very simple charge. So here's my Q. Okay, this is a charge. Let's say it is a negative charge. So here's my negative charge. Now if I wanted to draw the electric field lines around it, so remember that if I draw an electric field line, I'm representing with straight lines the vector that represents the value that a positive charge will experience. So if I have a positive charge here, he will be attracted towards, because positive are attracted by negative, so he will be attracted towards there. And if I have a positive charge here, he will be attracted towards here, directly, the shortest distance towards. So you'll see that the vector lines are all lines really just pointing towards the, and you don't have to make your arrows here, you could have made them somewhere in between, but this is a representation, just a graphical representation of the electric field, meaning that if I look at this, I can immediately see, okay, if I'm going to put down a positive charge, it will be attracted towards this negative charge. So this is what it will look like if I just drew the electric field for a negative charge. How about a positive charge? If I had a positive charge here, and so there's my positive charge, and I wanted to draw electric fields around it, all I'll do is I'll say, okay, if I put down a positive charge here, what will happen to it? It will be repelled, so it will be pushed away from there, and so away from there, away from there, away from there. Okay, so you can once again see, if I were to give a graphical representation of the electric field for a positive charge, this is what it will look like. Okay, now what will it look like if I were to draw these two together at the same time? In other words, what would the electric field look like if I have a negative charge and a positive charge nearby each other? Okay, a negative and a positive charge nearby each other. So let's look at that. Okay, so what would a positive charge experience if I put him anywhere here? So imagine now I put a positive charge right here. This positive charge will experience an attractive force in this direction and a repulsive force by this one. Okay, so they will just be a straight line. What about if I put him here? Well, here he will experience an attractive force in this direction and a repulsive force in that direction. So as I get closer towards this one, the repulsive force will be stronger, repelling it away. But as it's repelling it away, okay, he's getting closer to that one, so he's being attracted by that one. So the shape of that electric field will do something like that. The same goes for here. If I've got a positive charge here, it will be repelled. But as it's coming closer towards this one, it's being attracted towards that one. So it will do that. When it's close here, it will almost be directly repelled away. But as it's going past, the positive charge is being attracted by that one. Now the same goes for one that starts here. It's being repelled away, but as it gets closer here, it gets attracted there. So it makes this curvy line here. Okay. And that's the direction. The same goes for here. It's being repelled and then attracted by this one, so it makes that curvy line. But now at some point, as it's being repelled, like here, it's being attracted but it's more, it's going further and further away, okay, like that. And the same goes for this one. It's being repelled, and then it gets attracted by this one further and further away, until at some point it can no longer do that. So for example, at this point, it's just being repelled because there's no attractive Q. At this point, it's only being attracted, so it's going towards here. These ones do this, that one does this. Okay, I hope you can see my directional lines. Maybe I should do them in blue. Okay, so that's the direction. That's the, well, blue is not much more visible, is it? Okay, but in anyway, the direction is very important when we draw these. Okay, so obviously, if I want to do the lines in between here, they kind of curve slightly. So this one is still fairly straight. This one is still fairly straight because this one is still fairly straight. Very little influenced by that negative charge because of how far it is away. But as I come closer, I just get slightly more skewed lines. Okay, slightly more skewed lines. Okay, does that make sense? Okay, this one looks a bit ugly, but that's a very good representation, if I must say so myself. Okay, so that's what will happen if I have two same opposite charges, is between the positive and the negative. And positive charge will experience a force in that direction. Now, how about two negative charges? So I've got my charge, and this can be negative charges and positive charges. So here I've got two negative charges. Okay, so this one is slightly more difficult to visualize. First of all, what you have to understand is that if I were to put an object perfectly in the middle here, and we're assuming these two charges have the same size, so if I put something perfectly in the middle here, it would not experience any force, because the attractive force in this direction and the attractive force in that direction would be the same. So it's not experiencing any force. So anything that is on this line will not experience a force. Anything on the right hand side of this line will be attracted. It would have just simply been attracted directly, but because this one is also attracting it, it is curving towards this inside. So instead of just doing that, it is curving. It's curved. Am I going to be able to draw that? It is going to be curved towards. Do you notice it's not just straight, because as it's going along, this one is also pulling on it, but it's not pulling on it strong enough to pull it past this line. I think that makes sense. Okay, and then the same is going to go on this side. It's just going to be an opposite. It would have been just straight if it wasn't for that charge, but this charge causes it to also be attracted slightly in that direction, so it will move like that. Now, as we're going further away, or let's say we're closer here, then that line would just curve more. Okay, this line would curve more. Now the same is going to go for anything on this direction. Is I would curve like that, and I would curve like that, and I would curve like that, and I would curve like that. Okay, but as I'm going further away, the effect that this charge has is less and less, so that here that one has almost no effect. Okay, other than attracting in the same direction, and this one as well. This one's attractive force on a positive charge here will be in the same direction as this one's attractive force, and that's why it will still just be a straight line. And as we go around here, that attractive force is less and less and less, and so it curves slightly. I don't know if I'm able to show that slight curve. Curves slightly. Okay, so you can see slight curvatures towards it, and this one the same. So these will basically be straight, and then slight curvatures as I'm getting closer. This is difficult to draw. Well, difficult to draw nicely. And so I get my that is really a difficult angle. Now this might be the ugliest one you've ever seen, but hopefully you can just see what we're trying to show you and why there's this curved space. Okay, now let me show you just for the positive ones, two positive ones, it looks the same. So for example, I've got a positive charge and I've got a positive charge here. Okay, and these positive charges, this time if I consider a positive charge, just a simple positive charge here in the center, again both will be repelling it with the same size. Okay, and then in all along this line, as this line forms the symmetry, the attractive force or the repulsive force of them would be the same size. So it will basically, if something is here, both of them will repel it, so it will start going in this direction and going in this direction as it gets closer and closer to that line. Okay, so now let's assume we've got something a positive charge at this point, for example. So positive charge at this point will experience a repulsive force by this one, will repel it in that direction, but this one will also repel it in that direction, but slightly less. So it will be repelled in both directions, which means it will swerve away from here. So as we're here, it will start pushing it away, but then the other ones pushing away will also affect it, or this one will also start affecting it the closer it gets to it. So let me just, there we go. So it will push it away, initially directly away, until that other one's effects start working on it, and it will push it towards and away from there. So here again it will do, and it will curve more than that and push it away. Now, one thing about field lines, I haven't said it yet, but field lines will never cross each other. Electric field lines. And then this one. Okay, and we see the same thing happening in this direction. Okay, same idea. Okay, and also again, as we're moving further away from this one, the effect of that curve will be less and less until we get about here, where they start being simple straight lines, not really affected by that. And again, this one, it experiences a force in that direction, even though this one's effect is in the same direction. That's why this one will be a perfectly straight line on this side. Perfectly, well, that is not a perfectly straight line. Okay, there. This one, once again, they just become less and less curved, and same goes for here. This one goes straight, being repelled, goes straight, being repelled, and this one starts being repelled in that direction. This one goes straight, starts being repelled in that direction, and this one goes straight. That does not start straight. Straight starts being repelled in that direction, and this one starts straight, being repelled in that direction. Oh, I seem to be getting the hang of this. Okay, this one goes straight, start being repelled in this direction. And once again, let's say we've got something here. Initially, he will be repelled a lot by this one in that direction until he gets there in the middle, and then he stops experiencing a force. So there's no line in between here, just because as it's experiencing a force, eventually the forces of the two will cancel one another out. Again, this is a very ugly one, and I can maybe try to draw in another one just to get the symmetry right here. Okay, but you can see just once again the idea is the same, is that it looks like these lines are really pushing away at each other, and when we have two positive charges, those two positive charges are just, all of their lines are showing away from each other. And now just finally I want to show you attractive forces between two charges. So we've got, let's say, a positive charge, and let's say we've got a large positive charge and we've got a small negative charge. Okay, in other words, the force experienced by this small negative charge is small, while exerted. The force exerted by the small negative charge is obviously much smaller than the force exerted by this positive charge. So again, what will happen now? Once again, we must just find that we must just look at what will happen to a charge at any point. A charge anywhere along the center will still be straight from, remember we're looking at positive charges, from positive to negative. So in the center, it will be from positive to negative. Now, what about here? Now, if I have a positive charge here, it will have a very strong effect, and then only when it gets close will it start being attracted by this small charge. Do you notice that? Okay, same here. It will have a very strong repulsive effect, and only when it comes close will it start being attracted by this charge. Once again here, it will have a strong effect, and then only here will it start being attracted by this small charge. And then on this side, if it's just perfectly on this side, it will again just make a straight line in this direction, and in this side it will have a straight line in that direction, but I'm making it longer because the force is experienced further away from this one. And so we can see here it will have a strong effect, and then it will curve in that direction, but maybe it's not even close enough to experience a force. If it was, it will still make a curved line like that. Okay, so you see, I wonder if I'm going to be able to do this symmetry on this line. In this direction, turn towards there. In this direction, and then when it comes close, it starts turning in that direction. Pushed away, and then starts experience a force in that direction. Okay, I think I'm not doing too bad on this. Okay, there we go. And then here it starts just going off. Okay, like that. Okay, it's being attracted, but not enough to actually attract it in that direction. Here it's being attracted slightly. There it's pushed away, being attracted slightly, and then something like that. Okay, does that make sense? I think that's a beautiful sketch. I'm so proud of that one. But here you can see just the effect of on the lines, and I really think if you just sit and try this a little bit. Oh, sorry, this one is in the wrong direction. That should be away from the positive charge. I apologize, and everything towards the negative charge. And just notice how if I have one charge that are overpowering in size, then it will push away the lines if it's positive over the other one. And if these were positive and negative charges, if they were swapped around, it would look exactly the same, only they would the direction of these lines would be in the opposite direction, so it doesn't make a big difference. But thank you very much for watching. I hope you got to understand electric field lines and that it makes sense to you. We'll see you in the next video. I'll probably be doing some examples on Coulomb's law, electric fields and charges. See you there.